Lecture problem 4. An object originally at rest explodes into two fragments, m and 2m. What is the ratio between the kinetic energy of the mass m and the mass 2m? This explosion can be described by this very simple diagram. Before the explosion, the object is initially at rest, therefore its initial velocity is equal to 0. After the explosion, if I assume that the smaller piece is going to move towards the right with the velocity v1, the other piece, the bigger piece, has to move towards the left with a different velocity v2. This is very important because the total momentum before the explosion is 0, therefore the final momentum after the explosion has to also equal 0. This cannot happen unless the two vectors are pointing in opposite directions. Two vectors cannot cancel each other out unless they point in opposite directions. Since the net force at the moment of the explosion is equal to 0, therefore the momentum before the collision must equal the momentum after the collision. The momentum before the collision is equal to 0 because the object is initially at rest. The momentum after the collision is two parts, m times v1 plus the larger piece 2m times its velocity v2. Since the equation is one-dimensional, therefore we have only x component. 0 equals, I assume that the smaller piece is going to move towards the right, therefore positive mv1. The other piece has to be moving towards the left, therefore negative 2m v2. The variable m is going to cancel out. Therefore, the velocity v1 is going to equal 2 times the velocity v2. Now we are ready to solve for the ratio between the kinetic energies. The kinetic energy of the smaller piece, ke1, divided by the kinetic energy of the larger piece, ke2, equals, substitute each one of them by their respective expressions, 1/2 m, which is the smaller piece, times v1 squared, divided by 1/2 2m v2 squared. The halves are going to cancel each other out. The variable m is also going to cancel out here. The result is going to be v1 squared divided by 2 times v2 squared. Now let's substitute the v1 by the expression that we have derived earlier, which is 2 times v2. When you square that quantity, it becomes 4 times v2 squared divided by 2 times v2 squared. The v2 squared are going to cancel each other out, and the result is 4 divided by 2, which is equal to 2. Therefore, the ratio between the kinetic energies, the kinetic of the smaller one over the kinetic of the larger piece, is going to equal 2. Now, based on these results, let's make important conclusions. If an object is initially at rest, and that's a very important statement, and this object is going to explode into two pieces, and one of the pieces is twice the mass of the other, expect the smaller piece to have 2 times the speed of the larger one. Also, the kinetic energy of the smaller piece is going to be 2 times the kinetic energy of the larger piece. This is also true if the piece is going to break into two parts. One of them is 3 times the other. The smaller piece is going to have 3 times the speed of the larger piece and also 3 times the kinetic energy of the larger piece.